Right now, AI feels like it's absolutely everywhere, right? Like it's some overnight revolution that just appeared out of nowhere. But this isn't a new story. Not at all. It's actually an ancient one. We're going to trace this epic 2,000-year-long quest to create artificial minds. And it's a journey filled with brilliant thinkers, just breathtaking optimism, some crushing disappointments, and of course, a modern explosion that has changed everything. So let's start at the very, very beginning of this idea. So, the dream of AI, it didn't start with silicon chips and code. It started with myths and magic and these incredible master craftsmen. For centuries, we've been fascinated with the idea of artificial beings. What you're looking at here is a design for programmable automata from the 13th century, basically a mechanical band of musicians. It's just one piece of this long history. From Greek myths about golden robots to these intricate mechanical wonders, all of it expressing this deep, deep desire to breathe intelligence into things that aren't alive. Okay, so how did we get from those mythical creatures and cool mechanical toys to machines that can actually, think? Well, this first part of our story is all about how we turned that ancient fantasy into a real mathematical possibility. The bedrock of AI, the whole foundation, is this idea that human thought can be mechanized. This timeline kind of shows you the building blocks. It all starts way back in antiquity with formal reasoning. Then you jump to the 17th century, where the philosopher Leibniz imagined this universal language where arguments could be settled by just saying, let us calculate. George Boole eventually gave us the maths to do that, and then Alan Turing's theoretical Turing machine gave us the blueprint. He showed how a simple device shuffling symbols could imitate any process of mathematical reasoning. So, when the first real computers finally showed up in the 1940s, the stage was finally set. This ancient dream was about to become a potential reality. So, with the invention of the so-called electronic brain, this theoretical idea of AI suddenly felt very, very real. And that excitement, it led to the first big boom and the official birth of a whole new scientific field. To give this new field a direction, Alan Turing proposed this landmark challenge back in 1950, the Turing test. And it was brilliant because he totally sidestepped the impossible question of, can machines think, and asked a much more practical one. Can a machine fool a person into believing it's human? This gave researchers a real, tangible goal to aim for, even if it was a deeply philosophical one. And here it is. This is the moment it all becomes official. In the summer of '56, a group of scientists, we're talking pioneers like John McCarthy, Marvin Minsky, Herbert Simon, they all got together at Dartmouth College. They wanted to explore the idea that, and I quote, every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. And it was right there that the field got its name, its mission, and its founding fathers. After Dartmouth, the atmosphere was just electric. I mean, researchers were blown away by what their early programs could do, solving algebra problems, proving theorems. This led to this period of intense, almost unbelievable optimism. It's perfectly captured by this 1965 prediction from Herbert Simon. They truly, truly believed human-level intelligence was right around the corner. But, okay, let's ground those huge predictions in a little bit of reality. This is the tech they were actually working with. These are massive, room-sized machines with less processing power than you have in a cheap calculator today. It's an incredible contrast, right? They were dreaming of creating human-level minds using these colossal, primitive computers. Yeah, that early summer of optimism couldn't last forever. The sheer difficulty of what they were trying to do started to become painfully obvious, and our story takes a pretty dramatic turn. The promises didn't pan out, leading to a long period of disillusionment we now call the AI winters. So why did it all go wrong? Well, the researchers had seriously underestimated three huge hurdles. First, something called the combinatorial explosion. Just think of a chess game. The number of possible moves explodes with every turn. For real-world problems, the number of possibilities was just way too big for the computers they had. Second, a simple brute force lack of computer power. And third, and this might be the biggest one of all, the common sense knowledge problem. How do you teach a machine that water's wet, or that you can't push on a rope? It's all the billions of simple facts about the world that every kid just knows. And these problems had real-world consequences. Critical reports, like the Lighthill Report in the UK, led to massive funding cuts. DARPA, which was a huge early funder in the US, pulled back. The entire market for specialized AI hardware just collapsed, basically overnight. By the 1990s, the term AI had become so toxic that researchers and companies actively avoided even using the word.
But even during the coldest parts of that winter, new seeds were sprouting. The field didn't die out, it just sort of fragmented and evolved and laid the groundwork for a quiet but really powerful comeback.
So, two main approaches were developing at the same time. On one side, you had symbolic AI, the NEETs, who focused on rules and logic. This led to some pretty useful expert systems in the 80s. But on the other side, you had the Scruffies and their connectionist approach, using artificial neural networks inspired by the human brain. And after being dismissed for years, that approach was quietly being reborn. And this really nails the three key ingredients that fueled the resurgence. First, we got smarter algorithms. A huge one was backpropagation, which is basically a way for a neural network to learn from its mistakes. It let researchers train way more complex networks. Second, Moore's law kept delivering just massive increases in computing power. And third, the internet gave us big data, which provided the enormous data sets these new algorithms needed to learn from. It was a perfect storm. Which brings our story right up to today. That quiet comeback turned into a deafening roar, and it's pretty much all thanks to a single architectural breakthrough that unleashed this unprecedented explosion in what AI can do. Just look at this chart. Seriously, for years and years, public interest in AI was, well, it was pretty flat. Then 2022 happens, and it just goes vertical. This isn't just a trend, it's a phase shift. This is the picture of the moment AI broke out of the lab and got into the hands of millions, and it fundamentally changed how everyone thinks about it. Now, this modern boom, it didn't just happen overnight. It was built on a series of really critical breakthroughs. In 2012, deep learning had its ImageNet moment, where it just shattered records in image recognition. Then in 2017, Google researchers published a paper called Attention is All You Need. They introduced the transformer architecture. This was the game changer. It led directly to powerful large language models like GPT-3, and finally to the public release of ChatGPT at the end of 2022. 100 million. Just let that number sink in. That's how many users ChatGPT got in just 2 months. I mean, to put that into perspective, it made it the fastest growing consumer application in history. The quiet comeback was officially over. But this powerful new boom didn't just bring excitement. It brought some really profound concern. This quote, it's from an open letter signed by thousands of scientists and tech leaders in 2023, and it just captures the seriousness of the moment. The exact same hopes and fears from all those ancient myths were now being debated as a very real, maybe even imminent reality. So from ancient Greek myths to room-sized computers to the device that's probably in your pocket right now, the quest for an artificial mind has been one long, dramatic story. And now, with its capabilities advancing at this dizzying pace, the story is reaching its most critical point yet. The question is no longer if we can build these things, but what we should build and who gets to decide what happens next.